Hello and welcome. Today we're going to be looking at conditional probability. In this section, we will be learning how to read a two-way table to evaluate conditional probabilities. Conditional probabilities can usually be identified by the phrases given or given that. There are other ways that can signify a conditional probability, but these are usually the two popular ones. So say you go to school Monday through Thursday, find the following probabilities if you don't know what day it is. Well, I just said, what's the probability that today is Wednesday? Well, the probability that today is Wednesday, well, that's 1 out of a total of 7 days in the week. What is the probability today is Wednesday if we're given that you're in school? So if you know we're in school, that means that we know that it's Monday through Thursday, which is 4 days. So of those 4 days, one of those days is Wednesday. So that's the difference between a regular probability versus a conditional probability. And let's go ahead and convert these. Let's talk a little bit about how do we put these into a percentage form. So in this video, I'm going to actually keep things rounded to the nearest hundredth of a percent. So let's go ahead and take out our calculators and let's punch in 1 divided by 7. If we punch that in, we will get 0.14287. That should be far enough. And in order to turn this into a percentage to the nearest hundredth, I'm going to go ahead and move that decimal over like we normally have been. So if we move that decimal over twice, what does that give us? That will give us 14.2857. Now that's percentage now, but I said I wanted to do the nearest hundredth of a percent. So the hundredth of a percent, this is the tenths, that's the hundredth, so we're going to round to this part here. So here we have the 5, and the 5 says round that to a 9. So this will give us 14.29%. And then here we have 1/4. Well, we're used to 1/4. That's 0.25, which will give us 25%. And depending on your instructor, maybe they want you, if they want everything to the hundredth, then we might say 25.00% just to signify that we are going out that far. But if it's not going that far out, I'm just going to cut it off at the 25% if there's nothing after it. So we can shortcut this. If you notice here, we rounded this 8, right? We went out to this spot where we rounded that to a 9, which is 1, 2, 3, 4 decimals from here. So if it helps, if we're going to do that, you can either move the decimal, then round, or just think of saying, well, I need to go 2 more out on the decimal form, and then round this one to a 9, then move the decimal. So just be careful, make sure you're following directions and you're rounding appropriately. Okay, so back to what this says here, the way that we can write this part, that vertical line there, this says the probability of A given, or given that B happens. So we can say that this is the probability of event A happening. It's the probability of event A happening given that we know event B happens. So the probability of A given B says the probability of event A happening given that B happens. And there's other ways to word it. We could say if B happens, what's the probability of A happening? So there's different phrases, there's different ways to reword this. Okay, continuing on. So here we have the following two-way table. The following two-way table describes the gender and political party affiliation of a random sample of 200 people. So this is our example from previous pages or previous videos. So here we have political party, we have our gender on the left. Now if a person is randomly chosen from the sample, find the following probabilities. So what's the probability that that person chosen is a female? Well, the probability that that person chosen is a female, well, there's 200 people total. And of those 200, we could see that 88 of them are female. So that's 88 out of 200. So we go ahead and do that division. You'll get 0.44 for the decimal form and move that decimal over to get 44% or 44.00%. So that was just a straightforward, that wasn't a conditional. The next one, this is going to be our conditional. The probability that a female is chosen given that the person is a Republican. So if a random person is chosen from the sample, what's the probability that that person's female given that, or that we know that the person's a Republican? Well, if we know that they're a Republican, well, how many Republicans are there? There's 63 Republicans, and of those 63 Republicans, how many of them are female? And we see that 27 of those 63. So that's how you want to think about conditional probabilities. It's say, given that, we know this happens. So we know the person's a Republican, which means we're not concerned, we're not looking at Democrats, independent, or other. We know the person's a Republican. So you could think of the second part as meaning, oh, this is the total. So we're looking at, of the Republicans, what's the probability that a female is chosen? Okay, let's punch that in. You should be getting, I'm going to do this to 4 decimals out, so then when I move it, it'll be to the nearest hundredth. So that's 0.4286. And then we move our decimal over to get 42.86%. So there's a 42.86% chance that a female is chosen if we know that the person's a Republican. Next one, C, says the probability that the person's a Democrat given that they're male. So if you feel comfortable, remember, pause the video. So if you feel like you got this, pause the video, try to work through some of these, and then continue the video and we'll work through it. So the probability of a Democrat chosen, if we're given that the person is male, so we're given that they're male, so if we know that they're male, then we're looking only at the males. How many males are there? There's 112 males. And of those 112 males, how many of them are Democrats? So we're only looking at this row of males, and of those, 30 are Democrat. Plugging that in, doing that division in our calculator, you should be getting 0.2679. And in percent form, that's 26.79%. Okay. Part D, what's the difference? Well, these look similar, right? This says the probability that a male is chosen if we're given that they're Democrat. So notice that the order matters, right? These are reversed order. So this says, let's read it the other way. We could say if a person's a Democrat, what's the probability that they're male? So we know the person's a Democrat. So if we're only looking at Democrats, that means we're looking at 61. And sometimes it could help if you want to maybe circle just what we're looking at. If they're Democrats, so we're looking at those 61 Democrats, and of those 61 Democrats, 30 are male. And then we have 0. Should be getting 0.4918, and move our decimal 49.18%. Next one, what's the probability that the person that's chosen is an independent if we're given that we know the person's a Republican? So it sounds a little confusing. Probability that they're an independent given that they're a Republican. So the probability, well, let's see. We know the person's a Republican, so how many Republicans are there? I'm just going to circle these. There's 63 Republicans, and of those Republicans, how many of them are independents? Well, none of them, right? Because they're all Republican. So that's 0 out of 63, which is just a 0% chance. And that's an impossible event, right? Because you can't, there's no way you're going to get an independent if you know the person's a Republican. Okay, moving on to F. If a female is chosen, what is the probability they are an independent? So let's write this like in this format up above as a conditional probability statement. That's really saying, what are we finding the probability of? So I'm going to put it this way. What do we know the person is? It says that if a female is chosen. So we're given that we know the person's female. So this will be female. What is the probability they are an independent? So notice it says probability they are an independent. That's the probability. This part here is the probability we're trying to find under this condition that we know the person's a female. And after that, we just work it out. So we know the person's female, so we have 88 females, so given that they're female, so of those 88 females, how many are independent? 18 identified with the independent party. And we have 18 out of 88. So if you do your decimal and then move it over to get your percent, you should be getting 20.45%. So there's a 20.45% chance that a randomly chosen female will be an independent. And the last one, what is the probability a male is chosen given that they are a Republican? So I'm going to start setting up the statement. What is the probability a male is chosen? So we want to know what the probability the person is a male if we're given that they are a Republican. So that means we know they're a Republican. So we're only looking at the Republicans. We're looking at those 63 Republicans. And of those 63, 36 of them are male. Doing your division, moving your decimal over, you should be getting 57.14%. Hope you've enjoyed this video, and I hope to see you back for more.